Objective 6, state and explain the effect changing pressure or volume has on equilibrium position and Kc. So first of all, you have to realize that changing pressure is only going to affect the reaction if there's at least one gaseous reactant or product. If there's no gases involved, if it's only liquids and solids, then pressure really has little to no effect, not a measurable or significant effect. So there has to be a gaseous reactant or product, and then there has to be an unequal number of moles of gas on each side. So if only one side has any gas at all, that's fine. That's going to be the side most affected. So the side with more gas is more crowded because you got more moles of gas in the same space, so they're not getting to spread out as much as they usually do. So the more crowded side will be more affected by either increasing or decreasing the pressure. And again, I think about the bus. If you've got a bus completely full, 2 people in every seat, adding 10 kids or removing 10 kids from the bus really has a big effect on the people on the bus. But if you have a bus that's only a quarter full, so only half the seats even have one person in them, now when you add more people, it doesn't have nearly as dramatic an effect because there's lots of space left, and removing really has no effect either. So increasing pressure causes a greater increase in collisions on the crowded side. Notice it's a greater increase. Yes, it increases collisions on both sides, but the more crowded side is going to see the greater effect, and equilibrium will shift away from the more crowded side. Whereas if you decrease pressure, it'll cause a greater decrease in collisions on the crowded side, and equilibrium will shift toward the more crowded side. It'll pull the equilibrium back. Kc is not going to be affected since both concentrations are going to be changed. So initially when you look at Kc, let's say you increase pressure, so the more crowded side has more collisions, but then that forms more of whatever of the less crowded side. So both product and reactant are going to have a change in concentration, and the ratio is going to remain the same. The second part of that that I want to mention is that you could also change volume, and what you should realize is less volume is a way to increase pressure, or more volume is a way to decrease pressure. So if they state the question in terms of changing volume, I immediately think about pressure instead. Although you could think about volume, are you giving the more crowded side more space or less space? So if I look at this equation, what happens if volume decreases? Well, the first thing I need to notice is that all my reactants and products are gases. So I need to compare the amount. I've got 2 moles on this side, 1 each of the CH4 and the H2O, but I've got 4 moles on this side. So this is my more crowded side. So this is going to be more affected by a change in volume. So if volume is decreased, that means this side is going to become more crowded, pressure increases, more collisions on the product side, and more product collisions is going to lead to more reactant forming, and it's going to shift left. But again, it's going to end up with a change in concentration on both the product and reactant side, and Kc is going to remain the same.